Welcome to the online lecture series on power electronics. These days we are discussing about rectifier design and different type of filter that we can use at output to filter out the AC component in our output waveform, and somehow we want to get a nearly exact DC waveform after filtering. In our last lecture we discussed about capacitive filtering, uh, and today we are going to discuss the rectifier design with inductor used as an filter at its output. So, last time when we discussed the capacitive filtering, we concluded some of the things that can be summarized over here, that the value of current passing through these diodes were very high. For a load of about 5 ampere, the peak rating of the diodes that we needed was almost 78 ampere, 80 ampere, and the RMS value was also pretty much high, up to 20 ampere and so on. Also we saw that the impact of the surge current, the non-repetitive surge current, that also came out to be 426 or something like that. Due to those very high peak value of current that was passing from the rectifiers was basically supplied by the transformer, and hence the transformer ratings were also very high. In large industries, when we talk about poor power factor, we are basically discussing the huge inductive load in our power system, due to which a lagging power factor is introduced in our system, and the overall power factor of our system is very poor. But in this case, the power factor is low, but it is not due to an inductive load. That is in the case of the industrial loads. It is due to the conduction time of diode that is very less in case of when capacitances are used at output as a filter. Or these poor factor is due to the rectifiers. And also we have discussed this part, that if we want to decrease the ripple in our output voltage or current, there is only one way. If we are using a capacitor at output, that is I can increase the value of capacitance. But by increasing the value of capacitor, the drawback was that the current rating of the diodes were further more increased. Therefore there was a need to consider another type of filtering, and we are discussing now an inductive filtering. Now we will consider the same example that we discussed the last time. Design a rectifier with inductor as a filter. Previously we discussed a capacitor as a filter, but now we are going to discuss inductor as a filter, and these specifications are similar to those we used for capacitor filter, so that we can have a comparison between the different values, that is that of the peak value of the current passing through the diode, its RMS, its average value, the power factor of the system, the voltage ratings for the same rectifier design that was previously we used with which we used a capacitor filter, but now we are using inductor. Our power output is 5 kilowatt, and the output voltage is 1 kilovolt, and allowable ripple is plus minus 1%, and total ripple of about 10 volt on one side, so 10 into 2, 20 volt. Total ripple is 20 volt, and average load current is 5 ampere. For design considerations, we have to again go through the same procedure. The first one will be the selection of the type of filter, and this time we are using inductor as a filter. The second one is again is to consider the ratings of the diodes, which will include the peak value, the RMS value, and all those values that we have discussed in our um, last lecture when we considered capacitive filtering. Also, we need to consider the ratings of the transformer that we will be using for a particular load, and when using filter type, specific filter type. And similarly, this one, that we can also consider input filter. So the circuit diagram, in case when you are using inductor as a filter, the circuit diagram will look like something as shown here. Transformer at the input side of these rectifiers. This region over here, this is the full bridge rectifier, and this is inductor used as a filter. This inductor cannot be used at any location other than this. If we want to use it as a filter, so this is the location for inductor, and this is our load. In order to start our filter designing for inductor, we need to assume some things, and on the basis of those assumptions, we will progress our inductor design. The first thing is that we have to consider that the inductor used as a filter is large enough that it is capable of providing a constant load current, and which is 5 ampere in our case, in our considered examples. Whatever the value of this inductor, whatever the value of the this load current will be, the inductor should be able to hold that value, and average value of the voltage across this inductor should be 0. That is, there is no voltage drop across this inductor. The inductor is in continuous conduction mode. Continuous conduction mode is basically the mode in which the inductor value I, the value of the current through this inductor, will be equal to 0. And if it somehow this value is violated, this condition is violated, that is IL is less than 0 or equal to 0, in that case we can say that the inductor has gone into the discontinuous conduction mode, or DCM. So this is the case. So basically, when we say that we have a large enough inductor, and the ripple from the ripple over that load current is not such that the load current or the value of the current passing through this inductor at any instant goes to 0, so it is in continuous conduction mode. If somehow if either the ripple from that inductor is huge enough, due to which the current from that inductor is becoming 0, that will be discontinuous conduction mode.